engineer for structural technologies from the Middle East branch in Dubai, and I'd like to welcome you on our presentation on Precast Polymer Pump Foundations, Improve Equipment Performance. This is our last webinar series in our week-long series geared in educating, engaging, and empowering individuals in the industrial sector. Before we get started, a few housekeeping items. This is a pre-recorded webinar. All our audience members are muted during this call, but you may ask questions using the Q&A function that is at the bottom of your screen, which will be replied via email within a few days. At the end of this session, a survey will pop up. If you have time, please let us know how we did. It would be great to get your feedback, and your response will ensure that we're providing the best possible content that is addressing your needs. I'd like to introduce our speaker, Michael Gullah, Director of Business Development, Rotating Equipment Solutions. Michael has over 35 years of technical sales and marketing experience in the industrial market. Currently representing the Rotating Equipment Foundation Repair Division, Michael leads a team that offers turnkey service, including assessment, repair design, and field repair that includes grout, anchor bolt repair, full foundation rebuilds. With that, our pre-recorded webinar will begin. Just a reminder that please feel free to ask your questions using the Q&A function, and we'll reply to your questions via email within a few days. With this, I'd like to begin our webinar.
Our agenda today, we'll have a safety moment, and our precast polymer pump technology is called PolyShield, so we'll be using that single word through the presentation. We'll talk about PolyShield features and benefits. PolyShield is an alternative to a conventional reinforced concrete foundation, with anchor bolts and grout. So we'll talk about issues with conventional foundations. We'll show the difference in installation steps between conventional foundation and PolyShield. Provide a few case studies, some generic application examples, discuss standard versus custom designs, and then the quote and order process. And we have about 100 slides, a lot of photos. We'll be moving through them rather quickly, and we should finish in about 35 minutes and have plenty of time for questions. We'd like to begin all of our meetings with a safety moment, and in this webinar series, we're sharing Structural Technologies' response to the current challenges in our world. As a company, we are concerned for the health and well-being of our employees and our customers. We are implementing steps to ensure this daily, and many of them are outlined in this slide. With safety first, Structural Technologies and its licensees are maintaining operations within guidelines set by the government. We are partnering with clients to safely continue work on critical projects and developing plans and schedules for deferred projects. Thanks for taking time to listen to our safety moment, and now let's get started with the presentation. Just one slide about Structural. We were founded over 40 years ago. Our founder and current CEO, Peter Emmons, published a book many years ago called Concrete Repair and Maintenance Illustrated, which probably has the most detailed guidelines about concrete repair that are available. That's all we do every day is concrete repair. We're dedicated to that. We have subject matter experts for everything we do, including concrete repair and pipe strengthening, cathodic protection, etc. And our subject matter experts are nationally recognized and travel around the country and meet with customers and speak at conferences. We provide a very unique turnkey service, assessment, design, and field repair, as Chad mentioned. Instead of calling an assessment company and then a engineering design company and then a field repair company, you can make one call to Structural, and we can take care of your needs. Our vision is to be the industry leader in developing, implementing technology-driven solutions that make structures strong and last longer. We have technology involved in almost everything we do, such as PolyShield that we're talking about today, cathodic protection technology. We manufacture our own pipe wrap technology called VWrap. and we're using drones now to inspect concrete on elevated structures. We have offices around the country and in the Middle East. So Polyshield features, it's a simple precast, one-piece polymer concrete shell that's filled with concrete for pump and motor applications. It completely replaces a conventional system, which includes, your concrete foundation, your grout, your anchor bolts, and a base plate. Everything that we talked about yesterday on the webinar, if you were able to attend yesterday. It can handle process temperatures up to 500 degrees. It can be used to replace existing pumps, foundations, or installing a new pump foundation. And we'll talk about those details in this presentation. There's a wide variety of designs for either standard ANSI pump applications or custom designs. We use different polymer materials based on the process fluid, typically blue or red Novolac epoxy or vinyl ester. And these are aggregate-filled thermosetting resins depending on the corrosive conditions. The benefits that we'll describe in more detail: it's a safer installation, it's reduced installation time and cost, it improves pump performance and reliability by reducing vibration and corrosion, and reduced maintenance costs. So let's talk about those in a little more detail. It's a safer installation than a conventional reinforced concrete foundation because there's a lot less steps involved, so there's less chance for a safety incident. There's very little concrete removal compared to a conventional foundation. So overall, it's improved safety, and many Polyshield customers put a high priority on that feature. Reduced installation time. With a conventional foundation, as we talked about yesterday, it may take 1 or 2 weeks depending on the size of the foundation, including time for the concrete and the grout to cure. With a Polyshield installation, it can occur in less than 2 days. Installation costs are reduced as expected with the faster time. Man hours are reduced by up to 70%. There's also minimized rework costs. A lot of the things that can go wrong that we mentioned yesterday, such as softfoot or bolt binding, grout voids, are avoided with a pump foundation. If you're using a pre-grouted base, sometimes those bases are deformed a little upon installation, and some machining is required. So all of those costs are minimized as well. Performance and reliability benefits. The Polyshield material has high vibration damping characteristics. So it improves the mean time between planned maintenance. Some of the Polyshield users have provided vibration data showing that vibration was reduced up to 50% on the Polyshield versus a conventional reinforced concrete foundation. Increased corrosion resistance is another important benefit. Many of the units that have been installed have been in service for over 20 years with no issues, and they still look relatively new, and we'll show you some photos of that. And then reduced maintenance costs due to that lack of corrosion and on the foundation and the base plate. With less vibration, there's longer seal, bearing, and coupling life. So a lot of great benefits with this technology. Some history about Polyshield. It was a patented design developed here in the Houston area back in 1992. All of our Polyshields are manufactured here. Almost 10,000 units have been provided and installed worldwide, mainly through pump manufacturers and distributors, but also directly for end users. The first unit was installed in 1992 and is still in good shape. There's been some capital projects like new plant expansions here on the Gulf Coast and in the Middle East where hundreds of Polyshields were provided as foundations for all of the pumps for the expansion. Variety of markets, especially chemical and chlor-alkali plants with the high corrosion environment, paper mills as well, some refining applications, mining, natural gas, and food and beverage. And then there's a variety of applications in those markets, especially the corrosive applications such as acids and caustic and brine, etc. Our 44th installation in 1993 is still looking good, as you can see in the photo. That was at a chemical plant in Baton Rouge in sulfuric acid and caustic containment service. This is before we started adding color to the polyshield material. As we mentioned, the polyshield can be used for existing or new pump applications, and we'll discuss this in more detail, but for a existing application, here on the left, the pump and motor are removed. The top of the old concrete is removed so that the top of the rebar is exposed, and then the polyshield is placed on top of that and then filled with concrete, and then the pump and motor are installed and aligned. Very simple. For a new application, a rebar cage is doweled into the concrete floor, as you can see here on the right, and then the polyshield and pump and motor is placed on top of that rebar cage, and the polyshield is filled with concrete. So very simple process for either existing or new pump-based applications. So let's talk about the conventional foundation base, some of the issues with maintenance and insulation. Very similar to what we discussed yesterday. There's several parts to a conventional foundation system. That includes your concrete foundation, metallic base plate or some sole plates, your anchor bolts to provide clamping force and reduce tensile stresses in the concrete, and then the epoxy grout to bond with the concrete below and the steel up above to help reduce vibration and help with elevation. And there's environmental factors that affect this type of foundation, mainly chemical attack, dynamic loads from the pump or the motor, and then vibration due to those loads. Then here's some photos, examples of conventional pump-based maintenance issues. The base plate can get rusted and become cracked. There is it may be hard to see in this photo, but there is a crack right here across the base plate. Compromised anchoring, the anchor bolts may fail for various reasons, especially if the concrete and the grout below starts to fail. And then there's increased vibration as these foundations get old and start to fail. There's some more photos of excessive corrosion, deterioration of the concrete foundation. Sulfuric acid is a big application for polyshield, and here's some of the corrosion that can occur in that type of environment. Sometimes the concrete foundation is not bonded well with the concrete mat down below. Here's an example where a measuring tape was stuck underneath the foundation below the pump base, and they were able to stick it in there almost 9 inches. So there's not a good bond there between the concrete foundation and the concrete mat, and that can result in increased vibration of the pump and motor. So insulation challenges. We're eliminating everything that we talked about yesterday for a pump and motor: the surface preparation, the woodwork, the wood formwork for the concrete and the grout pour, the pouring time, the curing time, acid proofing if needed, and the quality that's required for a good concrete foundation. Those are all challenges. Base plate surface preparation time as well. The bottom of the base plate needs to be sandblasted and roughened up before grouting. Grout installation time can be long. Quality pouring is essential for maximum contact. We need to minimize voids to help reduce vibration. And sometimes those pre-grouted base plates are deformed and need field machining to correct softwood conditions. So all of these challenges add cost and take time with the conventional installation. As we mentioned yesterday, there's guidelines for conventional installation with API 686 and ACI 351 and you can see all the details required for a quality conventional installation. So the old concrete and grout needs to be removed. Dust control needs to be provided. Reinforcing steel needs to be repaired or rebuilt. There's a new OSHA silica rule for dust control to help minimize lung disease. The permissible exposure limit for silica dust was decreased by OSHA back in 2016. That affects the construction and manufacturing industries and a lot of concrete repair job tasks, especially concrete demo. OSHA guidelines provide controls and respiratory protection for a lot of different tools that are used out in the field. In some cases, a written exposure control plan is needed. And here's an example of our detailed form that we use. Concrete formwork can take a while to build per the guidelines. There's time required for pouring the concrete and curing the concrete and then removing the formwork. To prepare for grout, if there's a large grout shoulder, pins or wickets should be installed near the edges to prevent edge lifting due to the difference in coefficient of thermal expansion between the grout and the concrete. If a small shoulder is used, it's recommended that the length of the shoulder, which is dimension X, be less than the height of the grout. And we do see this on existing pump base foundations where there's a large shoulder and the grout is starting to crack on top of that shoulder. So the PolyShield polymer concrete solution eliminates this issue. For an existing conventional foundation, the concrete surface needs to be prepared properly for grout per API guidelines. You need to have an exposed fractured coarse aggregate. There are certain tools that work better than others. The concrete cannot be oil soaked or damaged, and it needs to be dry for epoxy bonding, and the edges of the concrete need to be chamfered. As I mentioned, the base plates may need machining and need to be sandblasted if the exposure time is short before installation. It's important to have rounded corners on the base plates to prevent stress cracking due to a square corner. And if the base plate's going to be sitting out in the field for a while before installation, an epoxy primer approved by the grout manufacturer should be used to protect that surface, and then that surface can be roughened and wiped with a solvent immediately before grouting. And then the machine is installed. The pump and the motor and the base plate are installed on top of the concrete foundation, and the levels are checked before grouting. Grout formwork needs to be built, and there's a lot of guidelines for that. The type of materials to use needs to be well braced to resist the grout pressure, needs to be watertight, need to have sufficient clearances from the base plate for grout placement and for air escape. Bond breakers can be used to prevent the formwork from sticking to the grout after the grout is cured. The woodwork needs to be sealed to prevent grout leakage, and as always, the shoulders and corners need to be chamfered. So here's an example of a very small pump base. The concrete foundation has been built. The surface has been prepared for grout, and the grout formwork is now built with a header box for pouring the grout into the space below the base plate. So here's a photo of the grout being poured, and then the grout is cured and the formwork is removed, and then here's the completed installation for a conventional application. There could be issues with grout installation, especially if you're not using a high-quality contractor. You could have foaming or voids in the grout or excessive air. You could have grout edge lifting if the shoulder is too large and you don't use wickets, as we showed in the previous slide. We see this quite often on some larger pump base foundations where the grout does not have expansion joints, and you can get a crack in the top of the grout that extends down into the concrete. Here's an example of a pump base that was regrouted and started up and had immediate vibration. And when the pump base was lifted off the foundation, none of the grout was stuck to the bottom of the base plate, implying that the base plate surface was not prepared properly. Here's a photo of a base plate being removed due to vibration, and as you can see, there's not enough grout in the middle of the foundation, so the contractor did not pour enough grout to provide close to 100% contact with the base. So there's a concave surface there. So that's the conventional installation. So you can see there's a lot of steps, a lot of time, a lot of potential issues, a lot of guidelines to follow. PolyShield is very simple, and here's how PolyShields are installed for existing foundations. We showed this photo before. You remove the existing concrete to expose the top layer of rebar. Some of the rebar may need to be repaired. The PolyShield shell is installed over the existing foundation. May need to use some lifting help depending on the weight of the PolyShield. The pump is attached and leveled. Suction and discharge flanges are matched. Shims or leveling bar may be needed to help with the elevation, and pipe strain needs to be checked and corrected. And then the PolyShield shell is filled with concrete. Portable vibrators can be used if needed to help settle the concrete fill, and concrete is filled to the bottom of the fill hole here so that the plug can be installed. And then alignment of pipe and electrical connections. We offer a PolyAdjust laser alignment kit if needed, and the pump and motor can be started up immediately after the concrete is set. For new foundations, you simply install a rebar cage on top of the location of the foundation system. We can provide rebar cage drawings if needed, and then you dowel in the rebar cage to the concrete floor. Install the shell over the rebar cage. We provide lifting lugs if needed. Leveling bars are an option, or shims can be used. Align the pump and motor, and there's the finished solution. So very simple, very fast, and it eliminates a lot of the issues with the conventional reinforced concrete foundation. So now we'll review some case studies. This is a power plant that needed to replace 3 vacuum pumps very quickly during a short outage in a wastewater treatment unit. Custom flat-top PolyShield systems were fabricated within 4 weeks, and the systems were installed and the pumps were returned to service in less than 2 days. So here's the existing foundation removed and reinforcement in place for the new PolyShield. PolyShield foundations were lifted with cranes, mounted on the foundation space, and then filled with concrete. And then here's the existing or the finished installation. So this is called a flat top because the metallic base plate sits flat on top of the PolyShield. The pump and motor are mounted to the base plate, not directly to the PolyShield. Here's another case study. PolyShields can also be used for, the PolyShield material can also be used for non-pump applications. So this was a sump application in a chemical plant. So this is a custom design for us, and the polymer concrete material offered longer-term durability versus other alternatives, and was also faster to install. So drawings were developed. The mold was designed. It was manufactured off-site. And then here's the inside of the precast sump. And then here's the grading system. And then here's the completed installation. And PolyShield material has also been used for long trenches as well. One more case study. This is a chemical plant pump foundation. This is the existing foundation with the pump and motor removed. The existing foundation is chipped away, exposing some rebar. In this case, the new pump and motor are going to be smaller than the old pump and motor, so that some of the old foundation will not be used. The poly shield is installed. Leveling plates were used to help with elevation. And then the poly shield was filled after the pump and motor installation, and then the perimeter of the poly shield was sealed. And then here is the finished installation. You can see that the concrete area that was not needed was touched up here on the left. And two more photos. So some typical application examples are corrosive conditions such as the acids in caustic and chloride dioxide and brine. Here's an example installation before and after. Here are self-feed pumps before and after. Sulfuric acid pump base before and after. A 300 horsepower Gould system before and after. And then here's another application, just to give you an example of how much better the polyshield looks after installation versus the conventional foundation. Here's a custom unit for a paper mill. This was a black liquor pump that would not hold alignment and had seal leak issues. Repairs were completed during a very short turnaround, and the customer reported continued increase in reliability 8 years later. And you can see here in the photo that it still looks in good shape. And here's a chlorine dioxide application. One customer in Louisiana requested 250 polyshield units for a chemical plant expansion. And after 15 years of service, you can see here in this photo that the polyshield still looks relatively new. It's a little dusty. It looks great, and the customer collected maintenance data and reports over 50% savings in maintenance costs. And vibration was less than half of conventionally mounted pumps. Answered standard polyshield examples. Here's the different models for Goulds and FlowServe and NEMA motor frames and the empty and filled weights of the polyshield. And here are the dimensions for those polyshield models. Minimum standard height is 10 to 14 inches, and 24 inches is the max height for a standard polyshield. All ANSI pumps and NEMA motors will mount directly to the ANSI polyshield. It's polyshield is designed for quick installation. The pump mounting pads, the standard pads, are good for process temperatures up to 300 degrees, and the alloy pads are used for up to 500 degrees. Typically, it's stainless steel, alloy 20, and Hastelloy. So here's the polyshield model 202, 203, C-face ANSI, close coupled pump, and those are some standard examples. We can also make custom polyshields for different applications. This is a non-ANSI pump and non-NEMA motor example. We have split case pump designs for 500 to 1250 horsepower motors. Split case pumps is a common custom design. Here's an installed unit with a seal pot bracket installed to the polymer shell. And here's a very large custom unit that's 13 foot long and 4 foot wide that was built for a paper mill. And here's a custom design for sulfuric acid application. We can also make polyshields for low profile applications. That's a solid cast base, so very small height. Below grade installations. A custom API style polyshield. API style pumps. Flat top insulation. This is the same photo we showed you before from the power plant. Here's some more examples of flat top insulations. Here's a very tall poly shield that was 56 inches tall. So that's another custom example. And this is an interesting application. It was a chemical plant with spring-mounted pumps to help with suction pipe strain. But the spring-mounted pumps were causing a lot of vibration and frequent bearing and seal replacement. And we worked with the customer to design an alternative solution where the customer installed high-density polyethylene pads that were grouted into the concrete floor below, and the bottom of the poly shield was a solid bottom. It wasn't hollow, and the bottom of the poly shield would slide on top of the polyethylene pads. And they tried it once and significantly reduced vibration, so they installed many more, and that helped them reduce maintenance costs on these types of on these pumps that used to use springs. The quote and order process, very simple. We simply need pump size, motor size information, process fluid and temperatures. ANSI quote time will be very short. Custom quote time may take a little longer. We have many ANSI units in inventory for quick delivery. A custom unit would typically require 4 to 6 weeks. Sometimes we need additional information if it's a low profile or limited space, or if there's obstructions or overhead clearance. We can provide drawings for customer approval. We have a large library of bare pump drawings for most of the OEM pump manufacturers, and then we can provide drawings for custom applications as well. Here's an example of a ANSI polyshield drawing. And typically we ask the customer to review all the dimensions, make corrections if needed, and then sign and approve. So in summary, these precast polymer foundations are safer, faster, they reduce insulation cost, they reduce vibration, corrosion, and maintenance cost, and they improve reliability.
Thank you all for attending today's webinar. We'll be extending today's webinar for 2 more minutes to allow attendees to ask their questions, which will be answered within a few days via email. I'd like to remind everyone to please fill out the short survey at the end. Many people have asked for the copy of the presentation. We will not be distributing the content or placing online, but please feel free to contact us to request a similar presentation or other topics for your team, facility, or company. We will be offering additional webinars in the future. Thank you all for your questions in advance, and we'll be back with you with answers within a few days. This is just a wrap up. Thank you for attending today's webinar. Please don't forget to complete the brief survey before logging out today, and thanks for your participation and input. Ramadan Kareem, have a great evening, stay safe, productive, bye for now.
الشغل